Добрий день. Привет, как дела? Okay, my name is Carlos Sanchez. I'm here to talk to you about continuous delivery for Kubernetes with Jenkins X. So, a little bit about... First things here. A little bit about me. I work at CloudBees, the company that hires a lot of people working on Jenkins and Jenkins X projects. I'm the author of the Kubernetes plugin for Jenkins, and I've been working on a lot of open source projects in my life, like Apache Maven, that you probably love or hate, one or the two. So let's start asking you some questions. Who's using Jenkins? Like everybody, okay. Who's using Jenkins X? Or tried? Who has heard of Jenkins X? Some people, okay, good. And who is using Kubernetes? Some people, okay. Who has heard of Kubernetes? Yeah, it's probably impossible not to have heard about Kubernetes, right? So I'm going to do a quick introduction on Jenkins X for those of you that haven't seen it yet. So Jenkins X runs on Kubernetes. So everything runs on Kubernetes, everything runs on containers, everything runs Kubernetes services. So Kubernetes all the way, right? Whether you deploy things to Kubernetes or not, everything runs on Kubernetes. And Jenkins X includes a lot of open source projects that you probably heard of or used or are interested in learning about. So obviously Docker for containers. It includes Nexus for like repository management, Chart Museum for Helm charts, and Helm, which is the package manager for Kubernetes. So Helm is probably the most, well, yeah, it's the most popular way to package applications for Kubernetes, where you package all your YAML files or all your services, all your deployment definitions, and you manage that as a package with versioning and everything. It also includes a Scaffold, which is a project from Google that allows you to build, we use it to build Docker images. So you can build Docker images with just Docker build. You can build Docker images with Canico, which is a project that Google created to build Docker images without needing the Docker daemon. So it's very interesting if you are running in clusters. And also allows you to use Google Cloud Build or use Jib, which is a project to build your Java Docker images from just a Maven file or a Gradle build. So we use that to build the Docker images. And Jenkins also uses Draft to generate Docker file and Helm charts for your project, so you don't have to manually do that. It will look at your project, detect the language. So if it's a Go project, it's going to generate the Docker file for Go and the Helm charts for Go. If it's a Java project, it's going to build your image based on, generate your Docker file based on one JDK image, and so on. So it's very interesting if you have projects that already exist, how to bring them into the Kubernetes world. And Jenkins X, when you import a project into Jenkins X, is going to do all this for you automatically. So you have two options to run Jenkins X projects and builds. So you can do the traditional Jenkins, so you can run a Jenkins master in Kubernetes, and Jenkins X will treat it as a Kubernetes deployment, and it's going to store data in Kubernetes that you can access using the Kubernetes APIs. Or the newest way that we are building is the serverless Jenkins X. So serverless Jenkins X is a cloud-native way of doing your builds. It uses containers for everything, so all your builds happen, all your steps of your build happen in containers. It uses YAML for defining your pipelines. So instead of using a Jenkins file in your Git repository, you use a YAML file, because who doesn't love YAML, right? And it uses Kubernetes custom resources to store all this data. So you can query, again, the API and get all this information from your cluster. In the last versions, we are using Tecton, which is a pipeline engine in Kubernetes that comes from the Knative build project. So it evolved into its separate project. It's a pipeline engine and uses the pods and containers to run the steps. So every step you have in your pipeline, you can make it run in different pods. So you can use different images for different steps, and it will share the workspace across all these steps, and it's gonna do this, concatenate all these pods into doing whatever pipeline you want to create. And the other project we use for serverless Jenkins is Proud. It comes from the Kubernetes infrastructure testing project. So it's what Kubernetes itself uses to manage their builds. It implements Git chat-ups, so you can talk to the bot in your GitHub pull requests, and the bot will respond to you and do the actions you tell. I'll show you that in a demo. And it handles the GitHub webhooks. So whenever GitHub sends a webhook request, Proud takes that and converts it into creating these Tecton pipelines. So you'll see, I guess it's going to be easier to understand in a demo. I was talking about the YAML files that you can use now to define your pipelines. So there's the concept on Jenkins X of a build pack, and we have two types of build packs. One is the classic one, which is for stateful Jenkins masters that run on Kubernetes. And we have the Kubernetes one for things that are built with serverless and Kubernetes applications. And this is two different projects. But if you want to try it today in like a Maven project, and I didn't realize I was in the middle of the screen, and you can just put this file into your Git repo, just say build pack Maven Java 11, for instance, and this is going to build your project as long as you follow some standards, okay? So it's opinionated, Jenkins X, so it will provide you these build packs that have specific steps across the way. You can configure them, but if you stick to this opinionated process, just this file is going to do your Maven build. It's going to do your Maven build in a container. It's going to create a Docker image with the results of your build and the JDK or the JRE, whatever is needed. It's going to create a Helm chart with those contents, and it's going to deploy that to Kubernetes. So this is all you need to get a full source code to deployment in Kubernetes pipeline. How that happens is it's using also extension. It has some concepts of extension and combination of pipelines. So if you go to this project in GitHub, Jenkins X Kubernetes packs and Java 11, you'll see, you'll see how one extends each other, right? So it's very simple for both Classic and Kubernetes. It's just that one extends the other. So if we look, you see import the Classic pipeline for Maven, so just one extends the other. But then if we look at the main file that defines what our pipeline does, you will see that some steps are defined. So this is all what's going to happen in your project. Just set the version automatically to the version to the next version in the POM file. So it will automatically increase the version. It will do a Maven install, in the next step. It will save the version for later, set the version in the POM. This is a lot of scaffolding that needs to be done. Tag the version, and then on the build steps, it's going to do a Maven deploy, and that continues, and I can show you some examples later. Yeah. And then you can have multiple pipelines defined also in the YAML file. So typically, Jenkins comes with 2 pipelines, one for pull request and one for master branch. And I'll show you in a second why is that. It's very important to know, although I'm going to show you serverless Jenkins and a bit of the future and the bleeding edge. And there's both worlds can coexist. You can have a Jenkins master running on Kubernetes, and you will interact with both serverless or a static master in the same way. But you can have both things. So if the new format of pipelines and Tecton doesn't work for you, it's very interesting for new projects and projects that are deployed to Kubernetes. But if you already have Jenkins files and plugins and things like that, you can also use the classic Jenkins inside Jenkins X, and you can continue to do everything you did, but in a more modern and better way, utilizing more resources and making sure your things are optimized, and also using all the Kubernetes APIs and benefits. So let me show you a demo. OK, so here I have this application running. And in the URL, you'll see is staging. Well, you probably don't see it, but this says staging, trust me. And so this great game that is shooting crocodiles with lasers. So I could be playing this game all day here. Yes, but I guess you wouldn't like this talk that much. So this comes from this project, Croc Hunter in Java. This is a Spring Boot application that just gets deployed into Kubernetes. So if we look at the Jenkins file, jenkinsx.yaml, you see it's I just say Maven Java 11 here. Now, I'm going to make a change to my application because, it's not for the environmentalists complain that shooting crocodiles with lasers is not a good example of how to behave. So we're going to make a change. The typical way you would make a change, you come here, you edit the file, and let's make a pull request and say no lasers. I want to create a new branch, and I want to create a pull request. No lasers. And what's going to happen, and I have this logged until here, so in a second we'll look at it, maybe here. Okay. All right. And let me go this down. Okay. So what happens is the bot that I was talking to you before that implements chat-ops has commented, and it says this pull request is not approved. This uses the owners file that is in Git to do the approval process and so on. It has added some labels, and it has triggered my serverless Jenkins build. Untied is another check that once it's mergeable, so once it's approved, it will automatically merge my pull request. So I can interact with the bot, and I can do very useful things like meow, and my bot will answer, okay? So the other thing, okay, I can myself look at the source code. I can do my review process. And I'm going to do it once the build finishes. And in a second, this should start happening here. Oops. I did it too big. So I can say get pods. I can look at, okay, so my pod is initializing here. So this is just, it takes whatever time it takes to start the pod, download the images and so on, depending on what node it falls. While that happens, I'm gonna show you, this is all running on GKE Google Kubernetes cluster. So I have my cluster running on Google. I have auto-scaling enabled. That's another great thing, that here you can enable auto-scaling just with one click. Auto-scale, this one, auto-scaling is on. So the more builds I have, the more machines my cluster is going to have, up to the limits I can set here. But if I'm not doing builds, my cluster is also going to auto-shrink. So it gives me the benefit of scaling up and down. And this is not yet working. So pod is still initializing. Pull request 6. Yes, pull request 6. We can take a look at what's happening with the pod. Okay, get pods, not describe. Okay, so what happened is that my pod triggered a scale up, so it's scaling up the cluster to fit this pod. That's why it's taking a little bit more than expected. Let me close. I'm thinking if I can kill something, but it's going to be a bit risky. Oh, okay, it happened. So these are the logs from my build happening in a pod. So it's all the Maven logs. It's doing its thing, it's running the tests, and it's building the Docker image here with a scaffold. And it's using Canico to build the image without needing root access to the Docker socket. So on that way, it's secure, or more secure. And it's deploying the image to the Google Container Registry, and is deploying it to a pull request preview environment. And I should get it soon here. So what happens is Jenkins X, for each new pull request that you create, is going to create a new Kubernetes namespace, is going to deploy your pull request to that namespace so you can view it. So I just commented here, PR built and available in preview environment. So I can go to this preview environment, which is not yet available. JX. Okay, there it is. So I can see my changes. You can see here my commit ID, which is the different one from the previous one. And I can see my changes, and it's no longer shooting lasers, but throwing fish to crocodiles, which is a lot more friendly, more kids friendly, right? So I see my pull request. I say, okay, I like what it is. Everything looks fine. What I'm going to do is I'm going to approve it. I'm going to do it with a different username because I cannot approve my own pull requests. So I'm going to go here with a different username and say /approve. So it's a bit like cheating, creating your own user for this. But so I see my comment. I say approve. Now, the bot says this pull request is approved. It has added the label, and in a second, this is going to be merged into master once it detects the changes. Once master is changed, the pipeline from master gets triggered. So everything in master goes into my staging environment. So remember, we have a staging environment, we have environments for each pull requests, and we have a production environment that we'll see in a second. So, okay, this was merged and closed, and everything happened, and now there's going to be another build happening that is going to build my master branch into staging. While that happens, I'm going to continue with the slides, and we'll come back to that later. And I'm going to talk to you about progressive delivery. So progressive delivery is not something new, but it's the name that groups techniques that already exist, and they all do very similar things. So progressive delivery makes it easier to adopt continuous delivery by deploying your new versions to a subset of users before rolling it to everybody. So think about canary deployments, blue-green deployments, incremental rollouts. So you want some users to get the new version, but not everybody. So let's say you want 1% of the users to get the new version. You want people in New Zealand to get the new version. So this is something that Facebook does, Netflix does, a lot of the big companies out there do. And then you get some metrics that will define whether, for that set of users, is the application succeeding, or the new version is working, or it's not working, okay? So you typically measure, I don't know, response time, HTTP errors, anything like that. And because continuous delivery is hard, I mean, you need ways to keep it safe. So progressive delivery makes that continuous delivery a lot easier or simpler. And nobody wants to just deliver anything, break all your users. It's really impossible to test all the things in production with production traffic. Because when you test, you basically are testing for things that you know that they can fail, but you cannot test for things you don't know that they can fail, right? And recently, we added progressive delivery to Jenkins X with canary deployments. And we use a project called Flagger. It's another open source project that manages the canary rollouts. And we use Istio and Prometheus. So let me start with Istio. Who knows Istio? OK, some people know. So Istio is a service mesh that allows you to do a lot of things in your Kubernetes cluster networking. It allows you to, for instance, to have TLS certificates between services, all encrypted communication between all the pods in your cluster, and allows you to have policies and control what's happening in the networking in your cluster, and get metrics out of everything. And this is what we're going to use, or Flagger is using in Jenkins X to get all the information. So we're going to deploy our applications enabling Istio, and Istio is going to send all the metrics from networking metrics from our application into Prometheus, which is the metric store. So what Istio does is intercept of these calls using Envoy proxy. So every pod has a proxy, intercepts all the calls, sends the metrics. So you don't have to touch your application. Everything I'm going to show you is basically you have to, with Jenkins X, you have to enable canary deployments, and you don't have to change your application. You don't have to send metrics, do anything. Istio is going to do that for you. Flagger automates the promotion of canary deployments. using Istio traffic shifting. So Istio allows you to say, send a percentage of traffic to this pod and another percentage to this other pod, or using HTTP headers, send things that come with this header to one place and do the whole traffic management. And it's very complex. It has a lot of features to do that. And Prometheus metrics Prometheus is the store where Istio saves the metrics, and Flagger is basically looking at those metrics to see what's the status of your new deployment. So when you install Istio, Prometheus, and Flagger, you can get the IP of the Istio Ingress Gateway. So Istio Ingress Gateway is where you have to send all your traffic to be managed by Istio. So this is the door between the outside your cluster and inside your cluster. If you send traffic there, then Istio rules will apply to that traffic. And what I have added to my application is a file that says it's a canary object on Kubernetes. So it's using Kubernetes custom resources. Flagger defines this concept of a canary file. And a lot of boilerplate here just to define what my canary deployment looks like. So I have a values YAML. This is all Helm configuration that gets injected into the canary file I show you, where I say I want to enable canary. The host I want to enable it for is this one. This is the gateway. That's a gateway that Jenkins creates for you. And in the canary analysis, I can say, how often do I want to check for the metrics? How many times I want the metrics to fail before rolling back? And the step weight and mass weight is how much traffic do I want to send to the new version and when to stop. So 10 and 50 basically means I want to send 10% traffic to the new version every minute. And when I get to 50% traffic, just go to 100. So it's 10, 20, 30, 40, 50, 100. So, and you can configure all that. And then on the metric side, we use Istio metrics. Istio request total is a metric from Istio that tells you the request success rate, so non-500 responses. And you say, OK, I want that 99% of my requests do not throw 500 errors. Check it every 60 seconds. And the request duration, so it's 500 milliseconds. This is the personal 99. So I want my request to not be over 500 milliseconds. If any of those metrics fail, and because threshold was 5, if they fail like 5 times, then Flagger is going to automatically roll by my application, and I don't have to do anything. So I can deploy on a Friday afternoon, knowing that if something goes wrong, it's going to be automatically rolled back. And the only way you need to do to get this working is the usual. With Jenkins X, you have a promote command to promote to production environments. So Jenkins X has the staging, again, staging, preview environments, production environments. So I'm going to take my version from staging, and I'm going to promote it to production, and then Flagger is going to kick in, and it's going to be deployed as a canary. I don't have to do anything special, just promote it from staging to production. OK. So let me start this, in case it takes a little bit. So Jenkins X get applications. This is the one I'm working on, Croc Hunter Java. In staging, I have the version 0018, and in production, the 0015. And let me see if this is the one. So this is the preview environment. This is staging. I'm going to refresh staging, and it should be the new version. So staging, yeah, staging has the new version already. While I was talking, this happened. So what I'm gonna do is JX promote Croc Hunter Java dash version 0018 and --env production. One thing I didn't mention is that Jenkins X uses GitOps for these environments. So we have Git repositories that define what's in staging and what's in production. And basically, a promotion is going to one of those Git repos and say, change this version to this new version. So if I go here, this is my production environment. I'm promoting the version 18. It just means change the version from 15 to 18 in a file. So I'm not changing my cluster live. I'm changing Git. So all my changes are recorded. And then based on these Git changes, my cluster change. So that's the concept of GitOps, where everything is defined in Git, and then my cluster reacts based on that. If I trash my cluster, I can always come here to Git and recreate the cluster with whatever information is in Git. And if I want to see who changed what, I can do that too. So this is being deployed, and quickly before this gets rolled out to everybody, I have to show you this. Yeah. Oops, what happened? I'm gonna go here. This is my production, and something happened. Oh, I think it's always a DNS issue, I think. I changed the DNS before, and I think I may have changed the wrong one. So let's get the IP, can get system. So I need to know the IP of Istio, which is this one, and no, 7. Okay, so that is the IP. I'm looking at the virtual service now. This is an Istio concept, and this is what Flagger creates by default. So I have these two hosts, so this one should work. Okay, that works. So there was some difference between one and another. I don't know. And this is this is the old version that's in production. And what we're going to do is we're going to hit this URL continuously to know what version is being responded with. So let's use this one. There it is. So I'm hitting, you see, or if you don't see it, I'm hitting continuously that URL, and some requests are getting version 18, some requests are getting version 15, right? If I go into, if I tail the Flagger logs, since 1 hour, you can see some events say new revision detected and advanced JX Croc Hunter Java weight 10. So it's now in a 10% of traffic is going to the new version. So let's see, 15, 18, and so on. The other thing that Flagger provides me, and right now it just says advanced to 20, weight 20, so now it's in a 20%. If I go to a Grafana dashboard that I have, I can see all these things graphically, the production version, the existing version, and the canary version. Refresh every 5 minutes, every 5 seconds. So I can see the incoming requests. So this is on the left we have the existing version, on the right we have the new version. So we see the success rate of the previous one, of the new one, and the metrics with the request duration and all the CPU, memory, all this stuff. And what's going to happen if this goes well, it's going to continue up to 100%, and all my users are going to get the new version. What I could do, because we still have time, is try to make it fail. So you see how it gets automatically rolled back. And I'm going to do something quickly. I'm going to do it from inside the cluster. I'm going to try to force the 500 errors. Okay, maybe this is going to be rolled out faster than I can break it. Let me see. Let's try to do it a different way. Curl here. Yes. Live coding, yay. Okay, so I'm generating 500 errors. The only thing is I'm generating them in both the existing and the previous, so this is going to fail too, but we don't, for the purposes of the demo, what I want is the canary to fail, and it will eventually drop the success rate, and we'll see how that gets rolled back. Because what I was doing this is the, so if I refresh, I get 18. If I refresh again, I get 15. So I'm getting one or another. And eventually, yes. So success rate just dropped like crazy. And what we see here is, let me show you up here. It says, well, here. Halt production advancement because success rate is at 0%, which is lower than the 99% I wanted. So it's stopping the rollout now. And if this happens, the amount of times I have configured, which I don't remember if for this demo it has 3 or 5, is going to automatically roll it back. So I'm going to let it here running, breaking the cluster, so we can see, okay, how it rolls it back. So this is how the Istio does it. It creates a virtual service. It sends some traffic to the primary, some traffic to the canary, and Flagger, looking at Prometheus, basically changes the virtual service 10%, 20%, 30%, and so on. And that's how it works. So I'm going to leave some time for questions. This is where you can find the demo application if you want to if you want to look at it with canary deployments and everything. So ask me one question. Yes. Yes.
Thank you for presentation. I have a question. Thank you. For example, we have large system, and we want to migrate our pipelines to Jenkins 6. And you say that we can use standard pipelines and plugins. And two questions. First, is it reasonable to migrate from standard pipelines to YAML? And the second question, could I combine both of these approaches?
Yes, so I would suggest to not migrate, start with new projects first, with the YAML pipelines and the serverless Jenkins, and especially if you are doing like Kubernetes applications today, because this is very recent. So for new projects may make sense. But yes, you can have in Jenkins X, you can have a static Jenkins master where you just do whatever you're doing today with Jenkins, and you can also have YAML and serverless pipelines. So you can have both at the same time. Yeah. Yes. Yes.
Hello. Have you changed anything regarding C jobs? I mean, how can I deliver my pipelines into Jenkins from Git? Is there any good approach?
From Git?
Yeah, I store all my pipelines in Git,
yes.
in repo, and I have not only like PR and master pipelines, maybe I have a bit more, some complex ones, and I wanted to deliver them into Jenkins. So currently we have a really custom things called C job, which fetch all the pipelines from Git repo, and using job DSL, we make it as pipelines. Is there any new approach in Jenkins 6 regarding this?
Yeah, in Jenkins 6 you would do import the pipelines, so it's JX import to bring them onto Jenkins 6. What Jenkins does, it stores everything as Kubernetes objects. So those are replicated and backed by the Kubernetes controller, master API. So you have replication and the benefits of Kubernetes. But yeah, you have to bring them over. I don't think there is a way to right now to scan your Git repo and bring everything. I mean, it's not hard to script.
Yeah. Because
it's all APIs and everything is Kubernetes objects. But I don't know if there is something that will, there's nothing that today, as far as I know, there's nothing that will go into Git and say, this is my organization, import everything.
Okay, thanks.
Yes, at the back.
Thanks for presentation. My name is Sergey. So it looks impressive, but it looks like you're using a lot of components to set up your pipeline. And these components, they're developed by human, and people are developing them right now, right? So, and kind of such variety of different components will bring instability by itself, right, to a system. So do you think it's a risk, and like how you approach, how you propose to mitigate it, how you do? Thank you.
Right. So there's a lot of components because we move from one monolithic Jenkins master that uses disk and files to save your data and everything into a microservice architecture where you have different services. One, something that processes the webhooks from Git. Then you have another one that takes over and does the creation of objects. Then the other one does the pipeline execution and so on, because we think this is the way to scale Jenkins to like thousands of builds and cloud scale. So that's the main motivation. I mean, you could install Jenkins. It's not going away. Jenkins, you can install Jenkins masters and everything today. It's just that it's not going to scale to a level, and it's going to have those benefits that Jenkins X brings to the table. I mean, obviously, Jenkins X is not for everybody. Especially, you need to have Kubernetes. So if you don't have Kubernetes, then that's a problem. But the idea is we're talking about optimize builds. So you can have auto-scaling clusters that auto-scale up and down based on how many jobs you have. You don't have to have VMs. You don't have to waste resources when there's no jobs running. If you have suddenly 2,000 jobs running, it's going to scale up and down. So it brings, with complexity, hopefully, there's some benefits that you can use in your organization. This.
Hello, thank you for the presentation. And I wanted to ask you, you're talking now about thousands of builds. And if I understood correctly, you're talking that various stages of builds will be done on different pods and nodes, which means communications.
Yep.
So do you expect that if we are running a really small scale, for example, there's just one team that doing a couple builds a day, there would be actually performance loss? And if so, what would you think will be the number where you would want to go with performance loss for a scaling upside of this story?
So it's not just for performance winning, right? With Jenkins X, you can import your project, and it will automatically apply these best practices. So you don't have to maintain these things too. You can, and I didn't show this, you can do JX create quick start, choose a template like a Maven project, and it will create everything for you. So you have something where to start. So it's not just scaling, but also ease of use. And yes, I mean, obviously, if you're going to do containers and you're going to start them on demand and so on, yeah, if you do one build a week, then it's going to maybe it's overkill to have a Kubernetes cluster just for that. But I think it's hard to find people or companies where the number of builds and things just go down or stay. They typically go up, and it's getting more use every time. So it's a bit of an investment into the future, I guess.
I see, thank you.
Right? Yes, ¿verdad? Okay. Okay, spasibo. I'll be around, so you can ask me questions later.